So today we will start the lecture number 4, which is mainly composed of instruction format and addressing mode of computer. Now computer architecture is defined as the study of component and their interconnection that form a computer system that we have already discussed. Now today we will discuss the instruction set. So an instruction set is designed for a machine is the primary architectural consideration. The complete collection of instructions that are understood by a machine is called the instruction set for the machine. That means for a particular task to be completed by a machine, the machine has to run a program, and for that writing of the program there is specific instruction for the specific machine to complete that task. So that's why it is called that the complete collection of instructions that are understood by a machine is called the instruction set. That means instruction set is particularly specific to the machine, or nowadays for the high level language it is broadly almost accessible by all type of machine. Okay, so what is instruction format? So instruction format is normally made up of a combination of operation code and some way of specifying an operand. So instruction is normally made of a combination of operation code. That means instruction is composed of an operational code, or shortly it can called as a opcode. Okay, and second most commonly by is location. That means it is composed of an operational code and specifying an operand, and most commonly by its location or address in memory. That means it is composed of an address. Also the addressing mode has to be defined. Okay, so that is the main format of an instruction. It is composed of an operation code. That means it is mainly operation code means it is the field that states the operation to be performed. That is, this field defines the various processor operations such as add, subtract, complement, etc. What type of operation is to be performed by the machine, that is defined in the operational code. The operational code may be, example of the operational code is add or subtract or multiplication, like that. Okay, so next is address. Address field generates a memory address or a processor register as an operation value. So to add two number you have to specify the number that has to be added. So that is specified with the help of an address. Where it is located, that is specified by an address. Next is mode. This field specified the method to get the operand or effective address of an operand. In some computer instruction set, the opcode itself explicitly specifies the addressing mode used in the instruction. A computer has various addressing modes which are next to be discussed in the next section of your lecture. So for example, suppose an instruction, I am going to give an example. Suppose this is your instruction add. Okay, and within that there is an R1, this is register R0, and so this is the type of instruction format. This add is commonly known as operational code, and this R1 and R0 it is the register or the address that has to be specified. Address field, these two are called the address field. Okay, next the type of address instruction. There are different type of instruction available. We have divided the instruction according to its length. So first of all there is 3 address instruction. Now the 3 address instruction, it is the general format. Actually the instruction length is basically depend on the number of address field used in it. So in the previous we have said that in this is the instruction, and in that instruction these two are the address field. So depending upon the length of this address field, we have divided the different type of instruction into 3 byte instruction, 3 address instruction, 2 address instruction, 1 address instruction, or the 0 address instruction. So these are called the address field. Okay, so fewer the address, the shorter the instruction. So if we get the, this is 2, this is the shorter the instruction. If this is another address field, so longer the instruction is. Okay, so fewer the address field, shorter the instruction, and long instruction will multiple address requires more complex decoding and processing circuit. The length of the instruction can be affected and by and affects memory size, memory organization, bus structure, CPU complexity, and CPU speed. To show how the number of address field affects a computer program, we will evaluate the arithmetic statement. Suppose this is your arithmetic instruction: x equal to a plus b minus c plus d. Okay, so this is an arithmetic instruction, and we will evaluate the arithmetic statement, this statement, with the help of the 3 address instruction, 2 address instruction, 1 address instruction, like that. And for this, load symbolic opcode is used for transferring data from memory, and store symbolic opcode, that means that we will use the opcode load, and next we will use the opcode store. Okay, load is used for the transferring data to register from memory, that means load is used to load the to register from memory, and store is used for transferring data memory from register. Okay, so load and store, this is the 2 instruction we will going to use. The symbolic opcode add and sub are used to arithmetic operation addition. Those who are familiar with microprocessor already know that the add and sub are the 2 symbolic opcode that are used for addition and the subtraction of different type of program. Now the 3 address instruction. So our main motto is we will evaluate this instruction arithmetic expression. Okay, we will evaluate this arithmetic expression with the help of the different type of address available, instruction available, that means 3 address, 2 address, 1 address. Okay, and we will use the symbolic opcode load to transferring data from memory to register, and we will use symbolic opcode store from transferring data from register to memory. Okay, so that is the 2 symbolic opcode, and we will also use the add and subtraction, the symbolic opcode for perform the addition and subtraction. Okay, now the 3 address instruction. 3 address instruction means memory address for the 2 operands and 1 destination need to be specified. We have to define the 2 memory address of the operand and 1 destination need to be specified. That means we have to perform the addition upon the 2 operand, that has to be specified in the 2 address field, and where we want to store the data, that has also to be specified in the 3 address instruction. It is also called the general register organization. So you will see the instruction format like that. This is your instruction. So add R1, R2, R3. This is the 3 address instruction. Here 3 address field are specified. 2 is used for operand, 1 is used for store the data of the final result. So this is the micro operation. Micro operation, you can see that this is the R1 where we want to store the result, and we want to add the 2 operand, that means R2 and R3 are the operand, where the addition is to be performed and the final result is to be stored into the R1. So that is the format of the 3 address instruction. Next, evaluate this. Suppose this is your expression. So we want to evaluate this expression with the help of the 3 address instruction. Then we want to write the add R1 A B. That means R1 is the destination where we want to store the final result, and this is the okay. So this is the addition, this is the addition, and this is the multiplication command. This is the symbolic command. Okay, here we want to final register, we want to store the result after multiplication of these 2. So this is the format of the 3 address instruction for the evaluation of this arithmetic expression. Okay, so next is the 2 address instruction. The advantages of the 3 address format is that it generates the short program. Obviously it generates the short program because we want to increase this address field length, so that's why the program is shorter. That is the main advantage. And the disadvantage is that it uses long instruction. Obviously it uses long instruction, that's why the program is short. Next is the 2 address instruction. The 2 address register or the 2 memory location are specified. Okay, this is very simple. Assume that the destination address is the same as that of the first operand. So suppose instruction as the name specifies, this is the 2 address instruction. So 2 address instruction, you cannot write the 3 address field like that. Add R1 AB, you cannot write the 3 address field, you want to specify the 2 address field. Okay, so that is the 2 address field is specified, and final result have to be stored in the first operand. This is the first operand, this is the second operand, where you want to perform the addition operation, and the final result has to be stored within that register. What is the content of that register? Suppose the content of this register is 2 and the content of this register is 3. So after performing 5, R1 is actually contain 5. Okay, so R1 value is to be modified. That is the 2 address instruction. Okay, so previously we have said that we have used the load and store command. Okay, here instead of load and store, we have simplified that. For the moving the data from one register to another, we have used the command move. You can also use the symbolic command load and store also, but here for the simplicity purpose we have used the move to transferring data from one register to another. So suppose this is your evaluation arithmetic expression. We want to evaluate this x equal to a plus b multiplied by c plus d. So first we want to move the R1. Okay, within that R1 we move some operand. Next add R1b. Okay, so a is stored within R1. Next R1b. So R1 is actually storing, this is the result of the, now this is the result of the R1. Okay, next R2c, R2d. So this is the R2 contains this. Next R1 R2, and R1 is again after multiplication, the final result of the multiplication again stored in the R1 with the help of this command multiplied. The first operand is always storing the, in the 2 address instruction, first operand always storing the destination. That means the whatever may be the result, that has to be stored in the first operand. Next we want to move the result to another register. So that is the example of the 2 address instruction to evaluation of this arithmetic expression. Okay, the program has to be longer. The disadvantage is the program has to be longer, but the advantage is that we can use the smaller instruction length. Next, 1 address instruction. 1 address instruction, 1 register name or the memory address. The single accumulator organization. It uses accumulator register for all data manipulation. You can only use 1 register only. So that is the main purpose of the 1 address instruction. You only can specify 1 register after the opcode. Okay, and there is a accumulator register in the microprocessor that is being used, or the machine that is being used for this 1 address instruction. So here you can see that this accumulator register is residing within the microprocessor or the machine. Okay, so suppose this is the instruction add x. So add x means the default is accumulator, so accumulator content is to be added with the register x content, and the final result has to be stored within the accumulator. The 1 address instruction is only based upon the accumulator. Accumulator is the main thing here. Okay, and what is accumulator? Accumulator is a special kind of register situated within the machine, and whenever you write the add x, then this content of the x and the content of the accumulator is to be stored within the accumulator. Okay, so that is the 1 address instruction. Next, evaluate this expression again. So here we are using load and store command for the demonstration purpose. Okay, so load is actually used, we have already said that load is actually used for transferring data to register from memory. So this is the memory content. Okay, so we have load A. Load A means we are loading the content, that means the accumulator, whatever may be the content of this memory A, that has to be loaded in the accumulator. Add B, so final result memory B, whatever may be the content of B, that is added with the accumulator. Accumulator means A, so again stored within the accumulator. Let's store T. Okay, store T means whatever may be the, that means it is moving from register to memory. So register to memory from accumulator content to memory T, memory address T. So here we are storing the result of this final A plus B T. Let load C again, then add D. Okay, so accumulator again content C plus D. Next mult T, that means whatever may be the content of the accumulator. This is the addition operation is storing. Now the accumulator is storing the C plus D. Now mul mult T, that is this final content has to be stored within the accumulator again. Next again we are moving the content from register to memory, that's why we are using the symbolic opcode stored. That means whatever may be the content of the accumulator, that we are moving some memory location X. Okay, so final result is to be stored in the X. So that is the demonstration of the load and store command, symbolic. Obviously this is not the actual command, this is the symbolic opcode, and how we evaluate the expression within the help of one address instruction. Obviously the program is getting more lengthy because we are using the sorter command or the sorter instruction. Okay, next zero address instruction. Here stack is used. Arithmetic operation pops two operands from the stack and pushes the result, also called the stack organization. So here we are using the stack. Okay, stack means like that, this is a memory address, suppose this is the memory and this is your stack. Okay, so this is your memory. So first number, if we push one number, that has to be stored here, next number stored here. Now if we want to pop the number, then first this number has to be popped, next this number has to be popped. Okay, so this is the last in first out concept in the stack. So stack organization is used for zero address instruction. Now evaluate this instruction with the help of zero address instruction. Okay, here stack is used. Suppose this is your stack, I have already said that this is your stack. So push A. So push A means push and pop. This is the two instruction associated with the stack concept. Okay, in the comment field the symbol TOS, you can see the symbol TOS is used, which is means the top of the stack. So top of the stack, this is TOS means top of the stack. So first when the stack is empty, we want to push A. So whatever may be the content of A, that is has to be pushed into the stack. So first the top of the stack contains this. Next push B. Now top of the stack contains this content of B. Next add. Whenever we perform the addition operation, the two number have to be popped and added. Now top of the stack now content A plus B. Next push C, push D. So top of the stack contains the contents of C, content of D. Then add again, top of the stack contains C plus D. Okay, this is the add. Next multiplication. So whatever may be the result of C plus D and A plus B, that has to be multiplied and stored into the top of the stack. Next, pop. So result has to be popped and stored within the memory address. Okay, so we have used, so this, you can see that this is the actual addition operation and the multiplication operation, and for that purpose we don't use any kind of address field. That's why it is zero address instruction. But zero address instruction is actually employs the principle of stack. That's why the total program execution is gets easy without specifying the any kind of address field. Okay, whenever we want to add these two number, previous two number has to be popped and added. These two number have to be popped and added. Next, multiplication, these two number, previous these two number has to be popped and multiplied. Next, store. So only stack concept is used for the zero address instruction. Without the stack concept we cannot use the zero address instruction. So zero address instruction means there is no address field specified after the opcode. So this is all about the instruction classification based on the instruction length. So instruction length, I have specified the type of instruction. First one, 3 address. 3 address means 3 register has to be specified, or 3 address field has to be specified. And we have also demonstrated how you can evaluate with the help of this arithmetic expression with the help of 3 address. Next, this is your true address instruction. Only true address has to be specified. And next we have seen how we can evaluate this expression. Okay, next, one address instruction, only one address is used. Here the concept is accumulator. Without the concept of accumulator we cannot use the one address instruction. And we can all then show that how we can evaluate this expression with the help of one address instruction. Next, the stack concept is introduced and zero address instruction is implemented with the help of this stack concept. And finally we have also shown that how we can evaluate this arithmetic expression with the help of zero address and the stack concept. Thank you.